Hey everybody. So in this video, we're going to be looking at sum and difference identities. So they tell us tangent of theta is 5 over 9 and cotangent of phi is 14 over 15. Both theta and phi are in the first quadrant. So here I've drawn two triangles like they would appear if they were in the first quadrant. So here, this top one, we have theta, and then over here we have phi. So it tells us that theta is 5 over 9. Well, we know that theta is the opposite leg over the adjacent leg. So if I come over here to theta, then the opposite leg is going to be 5, and the adjacent leg is going to be 9. Likewise, I can come down here to phi. Cotangent is the adjacent over the opposite. So that's going to be 14 over 15. And then it says, find the exact value of theta minus phi. Now here, this looks strange and confusing, but all they've really done is just rewritten the rule. Sine of theta minus phi is really no different than sine of A minus B. Instead of A and B, they've just given us two Greek variables. So theta and phi. So what we need to do is come over here to our triangles, and we're going to find the hypotenuse for each one. So we'll say 9 squared plus 5 squared, and then we'll take the square root of that. So here, this is going to be the square root of 106, and then we'll do the same for our phi triangle. And that's going to give us the square root of 421. So here, if I have sine of theta minus phi, let's write this out. So we have sine of theta minus phi. This would equal, so here, this is going to be the sine of theta times the cosine of phi. And that will be minus the cosine of theta and the sine of phi. So it's the exact same rule you have with A and B, except we're just changing our variables. So we'll look over here and say sine of theta. That sine of theta is the opposite over the hypotenuse. So this is going to be 5 over the square root of 106. We're going to multiply that by cosine of phi. So that's adjacent over hypotenuse. So here we have 14 over the square root of 421. Minus cosine of theta. So cosine of theta would be the adjacent over the hypotenuse. So this is 9 over the square root of 106. Times the sine of phi, which is the opposite over the hypotenuse. Now, when reducing here, you're just multiplying fractions. So we can just multiply it straight across. So we'll say 15 times 14, or excuse me, 5 times 14, and that gives us 70 over, and then we're going to say the square root of 106 times the square root of 421. And this is going to give us the square root of 44,626. Minus 9 times 15 is 135. And this will all be over the square root of 106 times 421. So again, it's 44,626. So here we could write this as one fraction. We'll say 70 minus 35. That gives us negative 65. And that's all going to be over 44,626. So remember that we are in the first quadrant. And remember that all of our trig values are positive in the first quadrant. So even though we got negative 65, our solution here should be positive 65 over the square root of 44,626. So we'll write that out. We'll say positive 65 over the square root of 44,626. Now, you can rationalize if your teacher or professor requires such, but this is going to be the solution here. All right, that's going to be all for this video. I hope you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.